So this reminds me, there was a piece by Scott Alexander recently where I think someone made a similar argument about them being statistical pattern matchers, and his response was, yeah, well, your mom is a brute force statistical pattern matcher, which burns up the internet.
Awesome. I am so excited to have our friend of the podcast, Rosie Campbell, on today. Rosie, welcome to Increments.
Thank you. Nice to be here.
So kind of the genesis for this conversation was that a few episodes ago, Ben and I recorded an episode on AGI. And I believe Rosie has some disagreements, some clarifying questions, that kind of thing. But I believe the point of today's conversation is just to explore the question of whether or not AGI poses an existential threat. I believe Ben and I are a bit less worried. I believe you are a bit more worried, but we don't really know what's going to happen. I think just Rosie's here to basically break up the little echo chamber that Ben and I have created for ourselves. So maybe we can start by just maybe a few words of introduction, say who you are, where you work, and why you have an interest in this topic.
For sure, yeah. So I work on the trust and safety team at OpenAI. I've had an interest for a while now in emerging technology and specifically artificial intelligence and the chance that it could be transformative. I studied physics and philosophy initially, and then I did a master's in computer science. I worked for a while as a research engineer at the BBC, and there I worked on a range of technology, broadcast technology, so all kinds of things. But one of my projects involved using machine learning to try and automate the process of framing shots or switching between different shots, so kind of automating a camera operator or a director. That's what got me interested in AI. I started reading a lot about it, and around the same time, I encountered the effective altruism movement and the arguments around AI risk and superintelligence. And I was like, at first, it sounded very interesting, but I was like, I'm sure if I look into this more, it will not seem to be as bad as it first seems, or I'm sure there's very smart people who have got solutions to these problems. But I think over time, I've just gradually not found as confident solutions or rebuttals to those arguments as I would have liked. I moved over to the US in 2018 to work at the Center for Human Compatible AI for a little bit. And then I worked at the Partnership on AI, which is a nonprofit that does sort of research and programs around responsible AI, and then moved to OpenAI about a year and a half ago. So I think that's basically it. I wouldn't say I'm confident in either way. And I do find myself playing a role when I talk to people in the rashless community who are very worried about this stuff as more like maybe taking your position. But I think that there's also a lot of reason to be worried. And I haven't, as I said, I haven't found strong rebuttals to some of the things I'm worried about.
Yeah. So maybe we should just start there. So there's maybe a decent chance that you've just heard stronger arguments in favor of reasons to be worried than we have. And so let's not assume our audience is too familiar with the subject. And so maybe giving us the pitch for why we should be worried, what some of the most maybe frightening arguments that you've heard that you haven't had satisfying responses for would be maybe a good place to kind of kick the conversation off. Yeah.
So I think there are two key things that would lead to AI having a, potentially a catastrophic outcome. One would be if it has the capability to cause catastrophe, and one would be if it has the propensity to cause catastrophe. And I think if we first take the capability one, it seems pretty plausible to me that we could, in theory, develop systems that are very, very capable in certain domains, certain important domains, potentially, even if they're not conscious, even if they're not generally intelligent in the same way as a human is, that they are good enough in certain key domains that they could potentially either be misused to cause widespread harm or could cause widespread harm themselves. Just as an example, I could imagine systems that are very, very good at coding or hacking being used by someone to cause financial crashes or hack into systems that are managing important critical infrastructure, that kind of thing. So one is that concept that I don't see why there should be a hard limit on the capabilities of a system like this. And then the other is the propensity aspect, which is why might it want to cause harm in this way? And I think, I use want in air quotes because I'm not trying to anthropomorphize the system. I'm not trying to say that it has goals or motivations in the same way as a human does. But if we're talking about systems that we're training through, for example, reinforcement learning or with human feedback especially, I think there is reason why a system might develop certain instrumental goals that would be counter to what humans would want them to pursue. So instrumental goals such as seeking power, such as like making sure that it doesn't get turned off, acquiring resources, those kinds of things. And I don't think we have great verification methods yet to check that these systems couldn't or wouldn't evolve certain aims like that. And so if you take those two things, the capability of a system to cause widespread harm and the potential propensity of it to cause that harm, both of those seem like relatively plausible to me. And I haven't heard good reasons why either of those, why we can be sure that either of those won't happen.
Yeah. So just a few initial thoughts. So on the capabilities thing, I kind of view AGI, or just to say artificial intelligence, as just any other technology. And so we could talk about just simple computer viruses. Computer viruses exist, and presumably the capabilities of computer viruses will improve over the coming years as we develop more and more sophisticated forms of ways to attack. And in parallel, there will be evolution of defenses against computer viruses. And so it is, I think, with all technology, where we invent more powerful technology, and it has unforeseen consequences. But in tandem, we develop better ways to defend ourselves against it. And so you have the evolution of, say, large language models, but then you also have, I believe, OpenAI is leading the charge on developing techniques to detect if text has been generated by large language models. So it's not to take a blasé attitude towards artificial intelligence and say it's all going to be fine and there's going to be no harms, but I don't see any reason to view it as anything that we haven't been dealing with for the history of technology already. So in that sense, I see it as just the next incarnation of technology. There'll be new things we need to worry about, and then there'll be new technology developed to counteract that. On the propensity thing, I guess I got a little confused when you said you're not trying to anthropomorphize AI, but then you also talk about like a will to power. And I guess, how do you conceive of a power-hungry system while also not anthropomorphizing it? Because that seems to be difficult for me to understand, I guess.
Yeah. So if I have a system, so I'll take that one, that last point first. So yeah, if I have a system like ChatGPT, for example, right now, obviously, it's just a language model. It's producing text. It's not taking any actions in the world or something like that. But I could imagine a world where we're trying to build something like Siri that's more capable, where I can talk to my little assistant and I can say, like, go and find me, go and book me a flight for the cheapest amount possible or something like that. And it can navigate to web pages, it can search for flights, and it can, make decisions and that kind of thing. In order to be very good at doing that, I think we would be wanting it to like learn a bunch of stuff about my own preferences, about like a model of the world, about when flights tend to be cheap or that kind of thing. And I think that when I say like motivations, it's kind of like that's sort of what I'm talking about. Like this, it's being trained to do well on tasks where it's like finding me cheap flights, for example. And in order to do a good job on that, it's going to develop certain sub goals or certain sub like models of the world in order to do that well. And so if you like scale this up, one way to make sure that it manages to book me a cheap flight, or at least one way it would fail to book me a cheap flight, is if it got unplugged or if it got turned off in a certain way. And if it is modeling that as one of the ways in which it won't achieve its goal, then it will like learn to take steps to avoid that happening. And so this is the kind of thing I mean by like power seeking. It's doing it instrumentally in order to be good at the thing that we're like training them to try and do well. I don't know if that makes sense.
No, it totally does. But that's where I guess we start to part, not part company, but where we start to maybe disagree a bit. Because I just don't see a conceivable future where you can train it and it becomes so, because this is like the Bostrom paperclip stuff, right? Like I see that there's a limitation with the large language models, namely the amount of training data is finite, and soon it's going to run up against like all the text on the web, and then the capabilities are going to start to slow down. I also think that you have websites that have bot detection software already. And so there's nothing necessarily like super scary about, is it Adept AI that's trying to develop this website? That technology, it's just a new way for software to interact with websites. And if it starts to do malicious things like try to steal people's passwords to get admin access to websites, then websites will develop technology that prevents it, as has already been happening with like Facebook developing like anti-bot technology. So I guess where I start to get skeptical with the whole subject is when we start to just talk about intelligence in the abstract as this unbounded thing that can linearly and exponentially increase into the future in this unbounded fashion. Because I see these systems as being very limited by the amount of training data they have. And training data is finite, and we're going to get great progress in areas where we have great amounts of training data. But after that, things are going to slow down. And so I think what Bostrom does is he talks about intelligence as this like magic potion that can just do anything. And as we get more and more of it, then you're going to get these crazy intelligent systems that can just overtake their masters. And I just don't see any conceivable technological route to getting there because these systems are very constrained in their capabilities. And we're already seeing the limitations of a lot of these large language models. And it's like they'll be able to navigate through websites, but I don't think they're going to be able to disobey their masters. I don't like it's still software.
So it seems like like, correct me if I'm misunderstanding, but it sounds like your main objection is the kind of capabilities axis of this rather than the, okay, cool. Yeah, that's helpful. You mentioned the detection stuff for generated text. Honestly, I don't have much faith in these kinds of projects. Okay. Like, I think, if you look at the accuracy results for these things, they're not great. And I don't think that there's anything inherent about the way that language models produce text that will forever be, there's no reason why they shouldn't eventually be able to learn to talk just like humans or write just like humans to make it indistinguishable. I think I'm not sure why that would be the case. And so I'm not super optimistic that we will just always be one step ahead. And I also think that, you mentioned like, if these systems try anything bad on websites to steal passwords or something, we'll have other technology that is like trying to counteract that. And I think the other technology is going to have to be just as powerful / capable / intelligent, whatever word you want to use, in order to do a good job of that.
But why isn't that possible? Because you could just use AI.
Well, so there is, there's a whole stream of work that's around like, can we do scalable oversight of AI systems with other AI systems to try and make sure they don't go off the rails? And like, I'm glad that research is happening. I think there's like a chance that this might work out, but I also think that for all the same reasons why you would worry about the first AI system not being aligned or doing bad things, we have the same worries about the oversight AIs too. And so, I think it's just very risky to rely on that being the path to everything being fine, because if there is some way in which it's very difficult for us to transfer our objective into the AI system properly without it learning incorrect objectives or having optimizers that are optimizing for the wrong thing, I think that seems to be like an unsolved problem right now. And so even if we have AIs trying to keep each other in check, those other AIs may also have these same problems.
I'd just like to understand the scope of your concern a little more. So I think in the conversation Vaden and I had previously, we sort of drew a distinction between risk from AGI, right? Which is just presumably some sort of being like a human with the broad capabilities that a human has to do anything, right? Not just some finite list of tasks, and then it like aspiring for some sort of power. Versus humans using more constrained tools for nefarious purposes. And it seemed like at the beginning, when you listed some of the concerns, they were more in that latter category. So you said, humans using some sort of software to perpetrate, forget what you said, fraudulent financial transactions or something like that. So I would view that in the realm of taking, humans using a specific tool for a bad purpose. And so that's definitely a risk, right? So there's definitely bad things you can do with specific software. And in fact, I think the AGI safety community sort of discounts that, which I think is a bad thing. But then I think, as you're sort of describing your concerns, there's this way in which we start talking about these specific tools, and then they sort of somehow, unbeknownst to anyone, develop I think take on a model of the world, or as Vaden said, a will to power, right? And then we're sort of sliding from this scale of humans using a specific tool for a specific purpose to this AGI, and we're not sure how we're going to get there, but somehow it's going to develop. It's going to go from this very particular optimization objective that we have programmed in to have, making its own objectives, etc. So I'm just, wondering if you can, I guess, is that right? Or can you clarify the scope of the concern, or where are you on that spectrum?
For sure. Yeah. So, I do agree that the AI safety community, I think, doesn't think enough about the malicious use of AI systems. And I think these are quite closely related. So what I'm trying to get at with this kind of idea of capabilities is, if we believe that someone, whether that's a terrorist organization or a nation state or just someone who thinks it's fun to cause harm or try and, for their own financial gain or something, could potentially wreak a lot of havoc with these systems. They have those systems have the capability to do a bunch of bad stuff, whether that's through generating deep fakes and doing mass persuasion campaigns, whether it's through hacking in. If we believe that a motivated actor could cause a bunch of harm through those systems, to me, that suggests that the AIs have that capability, and they just need to be directed in the right way by a person to do those things. And so a lot of the stuff around deceptive misalignment, for example, I think is kind of later down the line. I think if before we get systems that have the propensity to do these things, we will have systems that have the capability to do these things when directed to by a motivated human actor. So if we all agree that that's a risk and we should be worried about it, we should find ways to ensure that the systems have limited capabilities, or put safeguards in place so that they can't be misused like that. I think that would get us a lot of the way to solving the problem. If we were able to put those bounds around these systems reliably, I think we'd be in a much better place. And then I think there's the sort of additional step, which is, okay, if we have systems that have these capabilities to wreak harm when they're pointed in a certain direction by a motivated human, is there a risk that these systems might also develop the propensity to use those capabilities to cause harm in a way that isn't directed by a human? And I personally think that's a much more controversial claim. And so it kind of surprises me. I always assumed that most people who are skeptical of AGI risk would be more skeptical of that claim, the propensity claim, rather than the capability claim that, there is a level at which these systems could cause massive harm. But I just did a Twitter poll earlier today, and it seems to be much more people are saying about the... Yeah, I was surprised by that. Yeah, people are more...
I clicked capabilities on that one.
Interesting. Okay. Yeah. People. The thing that is winning out is people not believing it would ever have the capabilities to wreak that harm. So this is... I find this surprising because, as I said, I think most people probably could envisage a world where a motivated actor could cause harm with these systems as they get more advanced. But I also do think that there is this risk of, or at least there's no obvious solution as to how we can guarantee that a system wouldn't develop incorrect objectives or deceptive alignment. If you're being trained to do a certain thing through reinforcement learning during training, and you want it's so hard to talk about this without anthropomorphizing it. I'm not trying to anthropomorphize. It doesn't need to be a human-like general intelligence. It just needs to be a system that is being trained to do a goal. And when you train a system based on feedback in this way, sometimes the optimal way to get those rewards is to develop what's called Miser optimizers that try and optimize for a different objective. And it can look as if the system is optimizing for the objective that you think you want it to be optimizing for during training. And then if you deploy it in the real world where the distribution is this is a problem called distributional shift. If the distribution is not the same in the real world as it is in training, then you can get very different behavior. And this has been shown in toy examples already as a problem. And so I think the fact that we have already seen this happen in toy examples, obviously nothing that's going to cause huge problems in the world right now. If you do scale that up and imagine these being trained in to have more capabilities and being deployed in critical infrastructure or other places, it seems pretty worrying to me that we haven't managed to solve it even in the toy examples, and we're considering kind of scaling that up and putting it in more and more places, more and more systems.
Well, so I honestly can't tell if what you're saying is science fiction or if it's totally banal. And what I mean by that is your answer to Ben's question is okay, the fact that you can have these AI systems when directed by a human being causing harm indicates that they can probably cause harm when not directed by a human being as well, or at least they will gain that capability quite soon. And so I want to figure out why that doesn't apply to something as simple as a computer virus written in Python. So you have a human being writing some malicious code, and they release that code on the internet, and it spreads like wildfire. And it's now doing things that it's spreading to computers that the initial programmer didn't intend, and all of a sudden it's wreaking havoc and causing chaos. So this is malicious. It's now left the control of the individual programmer. But yet this is totally banal because we've been dealing with this since the dawn of computing and computer viruses, and we have systems that defend against this. And this is commonplace. And so what is the difference in your mind between an AI system and just a computer program doing something that the programmer didn't intend?
Yeah. So I think it's two key things. One is the virus is not being trained in a way such that it would like develop, that you would have this issue with it developing objectives. And also that it is not, intelligent, in quotes again, enough to have like a model of the world and to be able to do strategic planning. So I was having a conversation with someone the other day where I was playing the role of you guys in this. And I was like, well, how come when I don't open my browser, the act of me being like, please open my browser, is that not the same as like, please make me a paperclip factory? And like, why is that not suddenly causing the world to end? Like, I'm giving this computer a task. In order to complete that task, it has to make sure that it doesn't get turned off. So why is this not the same problem? And I think the answer that I got in return is, two things. One is, yes, it's not been trained to have those objectives in a certain way. But I think the more relevant one is there's no like strategic thinking or planning or modeling of the world that is going on when you're instructing the computer to do that. It's not thinking ahead to be like, oh, Rosie might turn this computer off, I better make sure she doesn't. If it did have that level of intelligence and it had the capability to ensure that I didn't turn off the computer by, I don't know, causing some big crash in the world, then we would have a similar problem. But
what makes you think like a reinforcement learning algorithm is like thinking ahead or planning strategically or developing a model of the world?
And what makes you think that like a normal program isn't?
So I don't think it is right now. I think the argument is if you are repeatedly training these systems, then that will become a useful way to get reward. So if I am training a system to try and say I'm trying to train a system to negotiate with people, like a sales assistant or something, and a sales AI system, then probably it's going to do better if it learns how to negotiate people. It's going to get, like, if I'm rewarding it for like when it manages to sell something at a higher price to someone or whatever, it's going to try a bunch of different strategies, and eventually it's going to find strategies that work well. It's going to get rewarded when it sells it at a higher price. And probably one of the strategies it's going to figure out is like, oh, it's good when I can like persuade this person that this is a great thing for their lives. And if I have a good model of their lives and what they like and what they don't like, I'm going to do a better job of persuading them that they should buy this thing. So it's just like an instrumental thing that will arise like by like rewarding or not rewarding a system. It will sort of learn that having a model of the world is useful. It will learn that certain capabilities like persuasion are useful. And over the time, I would expect those to do better. And so we will see systems that sort of tend in that direction.
Yeah, well, I guess I would disagree with the idea that normal programs aren't thinking ahead. When you have a complex program with a series of if statements, this is the program thinking ahead. If this happens, I'm going to do the following thing. If this doesn't happen, I'm going to do this other thing. And then that can get arbitrarily complicated. And so I wouldn't agree that computer viruses don't have the capability of thinking ahead. I just think it's done in a different fashion than reinforcement learning. And second, I don't think reinforcement learning is necessarily more powerful than conventional ways of writing programs. I think it's a tool that is applicable in some circumstances, namely when you have a lot of repeated gameplay and easily defined reward functions. But reinforcement learning isn't just some super powerful thing that can write better programs than other systems. It's a tool that can be used in some circumstances, just like supervised learning can, just like unsupervised learning can, just like semi-supervised. And let's not forget just conventional programming.
Yeah, just to be clear, I'm not suggesting that reinforcement learning is like uniquely bad in this way or dangerous in this way. Just that I think this is like a useful one to use as an example. Like if we manage to build like an actual human level AI or super intelligent AI using good old fashioned AI programming, well, whatever it is, then I think we might have similar problems. I think that the underlying thing is just like, this idea that it's useful to have models of the world. It's useful to have certain capabilities. If you're trying to build something to solve arbitrarily complicated tasks, to do a good job of that, you need to develop these capabilities. And I think just reinforcement learning is kind of a clear way that I at least to me seems kind of clear how that might come about, especially because I think that's often used and is useful for situations where it's very difficult to specify exactly what the objective is. If you can write a computer program to solve it just in traditional programming, then like that's probably a much more efficient solution. But for tasks that are ambiguous or complicated or hard to specify in some way, I think that's when you get benefits from using something like reinforcement learning.
I'm still trying to drill down on how much I disagree with you, or like how much your examples are meant to display the end of the world versus just like a severe problem. So RL algorithms have shown in the past that they can engage in like reward hacking, right? So I don't know, there's that famous video game, but I don't know which one it was, where instead of actually pursuing the intended game objective, it like spun around in a circle in some way to like maximize its points. Okay. And so I take your point that like, you could see deploying this system in the electrical grid or something in some way, and then it engaging in some unforeseen behavior, and then, oh shit, we have a problem in the electrical grid now. And like, to shut off the power to the city for a night and figure out what's going on. That is a very different problem than doing the same thing and then waking up to this system having like taken over the world and developed like, goals and aims of its own and an entire mental model of the world, the history and people, etc. And so which one of those situations are you worried about them both? Yeah. Just one of them? Because if you're just worried about the first one, I don't think we have much of a disagreement. But then at that point, I think the words Vaden used at the original episode was like, that's kind of a natural engineering problem, right? We test these models as much as possible in the lab. Mm-hmm. And then once we think we have a good hold on them and they're passing all our tests, we deploy them in the world in small situations at first, and then we ramp them up. Things will go wrong eventually, for sure.
Yeah.
That happens all the time. Bridges collapse, etc. Things happen. But that's, again, a very different problem than like actually waking up to the world being taken over by something. So, yeah. So just which one of those scenarios, possibly both, are you worried about?
Yeah, so I don't think they are that different. And I think, I'm worried about both. And I'm worried about the possibility that they are not in fact that different. So it might well be that we start deploying these systems and we start seeing warning signs, we start seeing things go wrong and we find ways to correct them. That might be the case, and I really hope that's how things go. It also might be the case that the systems, unbeknownst to us, they become, oh God, so hard to not use anthropomorphizing words. They become intelligent enough to realize that
it seems like at some point, though, you have to start anthropomorphizing, right? Like, I think the difficulty is inherent to the problem, because if you're assuming that they're going to like, if it's if it has the capability and propensity, is use the words to take over the world, presumably it's going to only do so if it wants to, right? So I think you're right in using that sort of language.
The reason I try and avoid it is because I think people think that I'm saying that it's going to develop these for the same reasons that humans might develop like needs for power or whatever else, that it's like just like, we've got certain drives that we have because of natural selection and everything else that make us do things. And I'm not saying that like that's just going to for some reason transfer to AI systems. It's like,
I see.
I mean, I guess there's a parallel in the sense that we are a product of that optimization process, and that has resulted in certain behaviors or things that we seek. And I'm saying that through a different optimization process, the AI itself might also develop analogous types of wants, even though it's not the same thing. So that's what I'm trying to say. But yes, if you buy that a system might develop some sort of internal goal due to a misspecification of the reward function or something like that, and it is intelligent enough to know, or it has like a good enough model of the world and of you to know that if it reveals that it has these capabilities, you will not deploy it in the real world. So going back to my sales chatbot example, if I'm telling it, I want over the lifetime of your existence, I want you to maximize sales, and it's like, cool. All right. So if I display risky, like dangerous capabilities during Rosie's testing of me, she's going to turn me off. And that's going to mean that I'm never going to get deployed in the real world and I'm not going to be able to maximize reward. So what I need to do is essentially behave as if everything is fine, behave as if I'm aligned and I'm just doing the thing that she's optimizing me for. No big deal. She'll deploy me and then I'll be able to sell loads of things and get the maximum amount of reward. So we might get to a point where there's incentives for the systems, and they're like smart enough in the sense that they have this model of the world and strategic planning ability that they will like hide some of their plans from us. And because these systems currently are essentially black boxes, it's very difficult for us to inspect to find out whether or not the things that they are actually optimizing for are the things that we want them to be optimizing for. Obviously, there's a lot of research going on at the moment into interpretability, which I'm really excited about and I hope bears fruit. But I've spoken to a few people in this area who are not super optimistic yet with the methods that are being employed. Like, we're finding out some things, but it's unclear whether we'll be able to really find out enough to be confident about these systems and their motivations in deployment. And so, yeah, I think that's sort of where the concern is coming from.
So here's one question and maybe a way to interrogate a bit more, both what you think and also hopefully convey a bit more about what this side of the conversation thinks. If you were to rewind like 10 years and describe ChatGPT to people 10 years ago, I think they would think of it as pretty close to AGI. It's a system which can answer SAT questions. It can have long extended dialogue. It could do all sorts of amazing things. It can emulate like a Linux operating system. It can answer mathematical questions. It can answer scientific questions. And now this is being deployed in one of the largest search engines of the world, Bing, and Google is about to do something similar. I'm not really that worried about this. And I'm curious if you are. And if you are, I'd love to know why. But if you're not, that maybe will convey a bit of what I think is just what we should expect to see in the future, which is new technology comes around. It can do a bunch of crazy new things and it's going to be deployed. There'll be some mistakes and errors that need to be corrected, but then it'll just be integrated into the newest round of technology and then we'll proceed. So I guess to repeat the questions or sharpen them a bit, are you worried about ChatGPT and not what it could do in the future or what like ChatGPT 11 could do, but current ChatGPT? Are you worried about that? And I just love to know if so, why? And if not, why not?
From a catastrophic risk point of view, I'm not very worried. I think it is, as any technology has, I think it has risks. I think it has downsides. It might cause, some people might misuse it in certain ways. It might cause people to believe the wrong things or whatever. There's all sorts of things like that could go wrong. But yes, from a catastrophic risk perspective, I'm not worried about something like ChatGPT. Yeah. I am worried about future generations of these technologies. And yeah, the point about, if we went back 10 years ago and we said, we told people about ChatGPT, I feel like this is just kind of games with definitions. Like, I don't really care whether people call this AGI. So OpenAI has a definition of AGI, which is it can do most economically valuable work better than a human. It's possible that by that definition, we may be already there or at least close to it. And, arguably it could do a lot of things pretty well. I don't want to get too hung up on the concept or the words AGI, because what really matters, I think, is this idea of like being very good in a few domains or a few capabilities that could sort of snowball or could give something a huge, powerful advantage, whether that's being used by a human or because it's got its own motivations. Yeah, I think that I think we're already seeing with something like ChatGPT, at least my interpretation is that it has got at least some kind of world model. Well, not world model, but like it's got some kind of model of concepts. You can do things like asking it to write a poem in the style of something. You can do all these things where you do like style transfer. And I feel like that does demonstrate some kind of, it's building these concepts internally that we can't directly look at, we can't directly inspect. It's not clear exactly how or why it's doing those things. And so it seems like it's plausible to me that we could expect that to continue and it could develop more and more complex internal representations. So
that is maybe another, what do you call them? Cruxes, like a big disagreement. Which is, so do you think that just scaling up ChatGPT will get us to whatever the hell we want to define AGI as? Because I am very skeptical of that. And I think that it's going to plateau as soon as we run out of text to train it on.
Even a more specific question is when you said, I'm not worried about the current iteration of ChatGPT, but I'd be worried about ChatGPT 11 or whatever. When you say that, do you have in mind the exact same training mechanism, but we just, it's got many more layers and much more data? Or do you mean, because one issue I think is when people envision like the future of a technology is they look at the new abilities that have been added on by something like ChatGPT over the previous version or whatever, right? That you go back 10 years, you look at how much better ChatGPT, and they assume that ChatGPT number X will then be X times better than that. But if you're if there's no new breakthroughs in deep learning and we're just training it by the same mechanisms, but just adding more layers and more data, then I think it's easy to mistake how much better that could actually be than the current version. So when you were saying you're concerned about like the next iteration or something, did you mean, trained in the same way, or like, what do you have in mind there?
I'm not really making any claims about the exact training method. So ChatGPT is currently a combination of like pre-trained transformer model and also reinforcement learning layers on top of that. And it might be that for ChatGPT plus in the future, whatever, we have another layer of training or some other method of doing it. I don't want to be too prescriptive about exactly how that will work, because I think we'll just develop different techniques over time, and some will be more effective than others. We'll combine them in different ways. I do agree that like if we were literally just limiting this to outputting text, the risk would be much, much lower. I think there's still a risk that maybe it could like persuade a human to do something on its behalf, or it could like produce code that someone executes for it and it could like do something like that. But like, I think the real risks occur when it can start to take actions and it can, and it has this world model sort of thing being developed. And so I think it could maybe develop something along the lines of a world model without being that risky if it was constrained in its ability to actually take actions. I think it depends what you mean, like in terms of, do I imagine it to be a scaled up version? I think it has to have these extra capabilities in terms of taking action. And I think, there may be other techniques that we use. In terms of the like limitations of training data, I guess one obvious response to that is we will probably be able to generate a bunch of training data through these systems, which might sort of like, So do you think that wouldn't be that helpful?
Yeah. So I don't know if you read the essay, exactly, by Ted Chiang, which I absolutely love, and presumably you have a different view.
I thought it was good. I thought it was useful. Yeah.
Yeah, well, so I thought it was brilliant. And like, we talk a lot about knowledge production and yada, yada, Popper, Deutsch, not going to go into that too much. But I think one test of if these systems are truly generally intelligent is if they produce new, let's say new ideas. And then you could get this unlimited amount of training data by training ChatGPT 5 on the output of ChatGPT 4 and ChatGPT 6 on the output of ChatGPT 5. And I just don't see any way that this is ever going to happen, because but this is a testable, falsifiable prediction. And this would be one of the big things that would make me quite worried about AGI, is if you could have this bootstrapping effect that you are getting new things out that you didn't possibly put in. That's just not combinations of existing things. And
that's interesting.
And so, like the reason I use such an epistemological lens when I think about this stuff, which again, I try not to use in this conversation because talking at cross purposes, is because I think if we're talking about intelligence, we are talking about knowledge in some direct way. And if we're talking about knowledge, well, epistemology is a domain of knowledge. And I just see these things being dumb pattern matchers, no matter how complicated and interesting they are. I think that they're just rephrasing existing stuff that we already knew. And so the reason I like Ted Chiang's piece, there's many reasons, but in particular, I like the idea that he just said he has a prediction that ChatGPT 4 is going to be trained on stuff that didn't come from ChatGPT 3. And I guess you have some insider knowledge. Maybe you're not allowed to say it, but do you know if that's the case? This is such an important issue for me because I don't think we can have world models and subtle manipulation and deceit and all this Bostrom stuff if we can't just have it producing original content.
Yeah.
Like if it can't be a blogger first, then I don't think it's going to be a malicious actor. And that's why I'm just very skeptical about a lot of this, these forecasts.
So this reminds me, there was a piece by Scott Alexander recently where I think someone made a similar argument about them being statistical pattern matchers, and his response was, "Yeah, well, your mom is a brute force statistical pattern matcher, which blends up the internet and gives you back a slightly, And I do actually kind of feel like that about myself. Like I think I am a brute force statistical pattern matcher. I don't really know what I am
Don't
doing.
say that about yourself, Rosie.
I'm okay. I've made peace with it.
You're a universal explainer, and you know it.
I don't know. I just don't feel confident that like whatever it is humans are doing, whether it's pattern matching, whether it's being a universal explainer, I don't feel confident that we wouldn't be able to build something like that out of silicon. But in terms of like the question, can it create new knowledge? I'd be curious to hear what you think. So if it could, if it was reading like all of scientific literature, if it managed to come up with something that was like, oh, it has this concept of like a certain kind, like it has this concept of chemistry. I know nothing about chemistry, so I'm probably going to say something stupid, but like it has some sort of knowledge of chemistry, has some sort of knowledge of some other field, and it makes this connection. It's like, oh, those like within its internal representation, it like understands somehow, or it figures out that this concept is the same over here, and therefore it like is able to produce some new scientific insight that combines these like
there'd be an easy way to test. Like I was thinking about this, like easy way to test. So you train it on all literature up to and the year before the light bulb was invented, and you see if it can produce anything like the light bulb. You train it on everything up until Einstein's relativity. See if it can produce anything like that. Just train it on every NeurIPS publication before the current year, and see if it can produce ideas of the next year. And I just don't see any systems being able to do that. And like when
except for NeurIPS, I bet you it could do a lot of NeurIPS papers.
Yeah.
There's a lot of bad CS papers out there.
But you could even do it. You could even do it with like art styles. You could train it on everything up to and including the Baroque period, and see if it produces the Realist period, and then the Realist period, see if it produces although there's like, who knows if it would necessarily produce the same thing that humans produced.
Sure, it might go in a different direction. Of
course.
But are you saying that you think that this is not possible with current systems, or that it's not possible with future systems that use the same techniques as current systems, or are you saying it's just not going to ever be possible with any systems that we could?
So I think humans are an existence proof that it is possible to get matter to do this.
Okay.
So I'm not saying that we will never be able to program it. I just don't think that we can program it using existing methods where. What I specifically mean is gradient descent on training data.
Yeah.
Because I think that gets us to induction, which I'm not going to go into too much, but I think that there are some philosophical reasons why you can't just get new knowledge out by taking existing examples. But again, this is a falsifiable prediction because you could easily set up experiments where you see if it produces the next round of inventions. And I don't know if that experiment has been run, but that would seriously give me pause. If you gave it everything up to the light bulb, and then it like starts spitting out images of light bulbs and like the actual recipe that you would need to follow, then I would be very surprised. But right now, you train it on the entire bloody internet, so of course it's going to know everything. But is it going to produce stuff that you like haven't read before? This is Ted Chiang's point. Like, is it going to produce a new piece, a new argument, something genuinely new? Like the closest thing that attempted to do this was Meta's Gattaca project, right, where it trained on all of scientific publications, and it was just spitting out absolute nonsense because it has no notion of truth. And if you're going to produce new knowledge, you have to have some notion of truth, and I don't think you can get that simply by statistical correlations between particular strings. So to your question, do I think it's possible? Absolutely, it's possible. But do I think that any of the existing systems that we currently have are going to get us there? No, I think we're making really powerful tools that human beings can use. And that's why I'm like so excited about AI, because we're going to make stuff that can predict the shapes of proteins, and we're going to make really great tools for essay writers and et cetera, et cetera. But I don't think that at a certain point in the future, it's just going to all of a sudden take on a life of its own, unless you mean it in the way of computer viruses and of YouTube recommender systems. So like when I think of examples of where this has happened, I can think of a number of examples, but AI safety folks tend to say, well, we don't mean it like that. That's just simple technology. We don't mean like YouTube recommender systems recommending conspiracy theory videos, although that could easily be described as like the technology getting away from us. But when we talk about it in that sense, I'm totally down for AI safety, because that's where it's just responsible engineering. Like a friend of mine applied at it was Anthropic research, and he's like, so why don't you guys describe what you do as quality control? And I think you can get the next but I love that. It was such a shout out to Michael. He's a listener of the podcast. And I just love the idea of describing it as quality control, because that's what it is. It's like you're releasing software and you want to make sure that it's not hurting people. And that's great. But it's when you get but in the future, it could start manipulating people, and it could prevent itself from being turned off, and it could take over the internet, and it could crash the stock market, and it could all that just seems like sci-fi to me. So
it's so funny because I feel like sometimes I'm like, we're not actually disagreeing. Like, I think I actually do hear AI safety people talking about recommender systems as a very good example of like a mini version of the problem we're talking about. The project that one of the projects I'm working on at OpenAI at the moment is something along the lines of like safety assurance. Like, how can we develop checks and balances that ensure that given a certain set of capabilities, we can be sure that it can't cause like certain amounts of harm, whatever else. Like, I do agree that what we want to do is bring a level of rigor and responsible engineering, safety engineering practices to these systems. It seems like where we disagree is just this connection between like the problems we're seeing with current systems, and then like if you
forecasting into the future.
Yeah,
exactly.
And I think so. You gave me the question earlier about like what makes you think that if we look at like from 10 years ago compared to now, how people are overconfident in like scaling up to see what would happen. And I think I would just like flip that over to you. Like I don't know how we can not be, I don't know how we can't be, how can we be confident that it wouldn't scale in these certain ways, or like
because of the reliance on training data. Because all these systems are based upon oodles and oodles and oodles of text data, video data, photo data, there are just many domains of interest where we don't have the data. So I'm not worried about AI going crazy there.
I think we will have the data eventually.
So for example, successful business plans. The only way you can ingest a business plan currently is by turning it into text soup, and then it just becomes text prediction. But I don't know how you could have a system which starts to predict successful business strategies to the point where you could start making companies and driving economic progress.
Why not?
The new, because it just turns, this is basically what Gattaca tried to do with scientific publications, and it was a complete failure, right?
I mean, I don't think it could do a great job of it now, but I do think that like you could break down the skill of business strategy into a few more sort of like sub problems and get things that are like good at those sub problems. And then over time you would get something that was good at the overall picture of it.
And you would have, let's be generous, 10,000, 100,000 different business plans. And so you have the labeling difficulty. And then you have something going on, which is very similar to what's happening with other generative models like DALL-E and ChatGPT, which is it produces a bunch of things. Most of it is nonsense or not useful. And then you have a human saying, okay, this could maybe be workshopped a bit. So I don't see, like if you ask ChatGPT right now to produce a business plan, it could do that for you. But it'll only ever be something which a human can work with and massage and shape and maybe draw some inspiration from, but then have to create. And so a business plan is just one example, but we're just going to hit fundamental limits on training data. And then a lot of these techniques are going to plateau. And so I expect there to be huge innovations in like video and audio, but robotics is going to be very slow.
So yeah, I remember you saying this in the last episode about like there's certain domains where we just won't have training data for, but like I think in the last one you gave the example of medicine, for example, but I think it is already pretty good at healthcare, medicine related stuff. You know, it does make stuff up sometimes, but overall it can be quite useful on that front. And like overall, I think like
useful in conjunction with a human, right?
Well, what do you mean?
You're not going to like, so I know that Hinton was predicting that like all oncologists would be obsolete by like 2020 or something to that effect. But oncologists are just taking advantage of machine learning technology to predict cancerous skin lesions and stuff. And it's extending their capabilities. And so it's being used to augment and improve the abilities of doctors. It's not making them obsolete. And
well, I think it will. I mean, yeah, I think there'll be some areas that are made obsolete just in the same way that all technology sort of does that to a certain degree. Yes, right now I agree that like it seems to be that these systems are better in conjunction with a human. But I think, if your point is there are certain domains like medical domains or healthcare that don't have a great set of training data, but we're already seeing these systems do like really quite well in these areas. It seems a strong claim to say that we wouldn't expect that in other domains. And I can imagine ways that we use these systems in order to make up for the fact that some domains have less training data than others, either by generating synthetic data or, if a lot of this does rely on something like RLHF, where humans have to sort of judge whether or not it's doing a good job, we might be able to automate some aspects of that using these systems. And so you could generate a lot more training data that way. I think it seems to me a little bit, I'm not sure what the right word is, but like to assume. Like
naive, just say it. Say it.
Short-sighted.
Yeah. Idiotic.
Yeah.
No, yeah, sure. Yeah, short-sighted. Like, it's like these systems right now are the worst they're ever going to be. And I agree, they have a ton of flaws. They're clearly not going to take over the world in their current form. But I just don't really feel confident that we can't. We've managed to solve. Like you guys are all about problem solving, right? We find a problem, we solve it. Like that's how things go. And I just feel the same way with like, there'll be a lack of training data in some domains. We'll find a way to solve that, and it will just keep going.
In some places, but I think where we have had massive progress in the last 5 years are where we have massive data sets. Other places we're going to be limited just based on the speed of human labeling. In other places, I just don't think it's possible
but we can automate that.
Training data. Well, in some cases, like, so how would you automate like scientific innovation labeling? I just don't know how you could possibly have a system generate new scientific insights. You could maybe make something that creates a paper where it puts artificial figures in and uses scientific words and makes things that kind of sound like papers, but they would be utter nonsense. And this is what
like that thing out of MIT. Have you guys seen that to generate fake math papers? No. It's amazing. I mean, it's like 15 years old at this point, but I'll put a link in the show notes. But you can just ask it to generate random math papers, and because math is, especially like certain branches of abstract math, are basically their own language, right? So it just puts in like the tensor product on the d-dimensional manifold, and puts in some symbols, etc. Right. But people have had some papers accepted to conferences written by this thing. But anyway, sorry, not to derail.
Whoa,
no,
that's terrifying.
Well, I think that was kind of the end of my point. Like the reason why I think we'll have progress in some areas over others is where we have huge amounts of data, but where we have difficulties labeling, progress is going to be slow. And there may still be incremental progress, but I don't think at any point it's going to just explode into the FOOM takeoff thing. That just seems to be implausible. But maybe I'm wrong. And that's why I like Chen Chang's point so much. Like, if you could create labels just using these systems in such a way that it's not like a Xerox of a Xerox of a Xerox, but it's actually producing new content and it gets sharper and sharper with each iteration, then I will be totally wrong. And then that's my opinion is falsified. But I just think it's Xeroxing the internet over and over and over again. And it's creating content that's been seen and heard before.
I mean, I'm glad. I think we do have a few empirical thing, like falsifiable things that we can wait and see what happens. And likewise, there are certain things that it would change my mind if it turned out it couldn't do things like that.
Yeah. So what would change your mind, just to make those nice and concrete? So what would you want to see that would say, okay, maybe we don't have to worry about AI safety to the same extent that I was worrying before?
Well, for one, I think if we had good interpretability techniques that solved some of these toy examples, I think that would make me a lot less worried. I think so. A lot of what I'm claiming is sort of, we don't know this thing can't happen. And so it's hard to think of a proof that would like for sure rule out any possibility of it. But I can think of things that would decrease my likelihood that something like this would happen. Yeah, if we did manage to come up with some test like the ones you've described where we like train it on certain data and it can't come up with new novel ideas, that would make me less worried. There's like a bunch of things like that I think that would happen. But I think, so to just quickly go back to the scientific advancement thing and like, would it generate papers? How would you judge that? I think what I would imagine is something more like it would be trained to do different components of scientific advancement independently. So it might be like analyzing data or like designing experiments or something like that. And I could imagine it getting good at like those sort of vertical things that then when you combine them, it sort of has an overall capability improvement. And so I think I'm just like a lot less confident than you that we won't find ways to make up for the lack of data problem by either splitting tasks into more manageable chunks or by like automating some of the data labeling creation process using these models themselves. So if that turned out to be much harder than I think it might be, if that doesn't work, then that would also make me less worried.
So for you, lack of data is the primary obstacle. So if we had an unlimited amount of data, you'd be at concern levels, basically. Like you think sort of the current generation of systems, if we scale up the amount of data, we're going to be in serious trouble. No. Okay.
No, I don't think that.
Why not?
I think there's, I don't know if data is the bottleneck or if techniques are the bottleneck or size of the model is I don't know what is the bottleneck. I just think that whatever the bottleneck is, there's enough incentives, commercial incentives to solve that bottleneck that we will. I think we've seen that happen already to a certain extent.
So no matter what the hurdle is, we will solve that problem because we're all about problem solving. But I'm not.
Yeah.
I'm not saying that every problem will necessarily be solved. There's all sorts of factors which could get in the way. For example, AI funding could just cease. It could be a stagnation and people just stop working on it.
This could happen.
So there's all sorts of reasons why I think that although problems are solvable, not every single problem will always be solved. But you seem to think that we are inexorably on a step towards AGI, no matter what.
It's more like there are a bunch of problems that people thought might halt progress and they seem to have been overcome. And so it seems, I guess you won't like this because I'm using induction, but like it seems like in the past we have found ways to overcome them. So I don't see why we should be sure that we won't in future. It may well be that one of these problems does in fact turn out to be insurmountable, but I wouldn't want to count on that as the only thing keeping us safe, given that we've seen progress get through problems like that.
So your concerns aren't even necessarily grounded in the approach to the current technology. It's more just the field. We have a field of people trying to create automation of various kinds, and you're just worried that entire field might go off the rails in some sense. So it's more that there's like clearly huge commercial incentives and social incentives to create this kind of technology. You guys have pointed out in previous episodes just like how amazing it would be to have something that could solve society's problems, which obviously I totally agree with. If we could make sure it's pointed in the right way, this would be amazing. So there's going to be I think, pretty inevitable march towards trying to build these like generally capable systems, at least in certain key domains. And whether or not that ends up taking the form of the current systems or like we find some other way to do it, it's that overall goal to create systems that have these generalized capabilities in key domains to solve problems that humans struggle to solve without assistance, that I think is the concern. I see. Okay. I'm not sure if this came across in the previous episode, but let me just state for the record that I'm not counter thinking about like AGI safety, full stop. Like if we had some sort of breakthrough in how we're developing automated systems, I could see starting to be concerned about that, depending on how it's developed. I'm more pushing back against grounding fears of AGI in the current technological landscape, which I don't think is feasible, of like bringing out the sort of calamity that people are worried about. Anyway, I just wanted to kind of state that for the record, that it's not, I'm not like, I don't think I could see there being a world in which I would be worried about AGI based on how it's being developed or something. I don't know what that world would look like. I can't even begin to sketch it out, but I'm more pushing back against the connection that people seem to be making with like deep learning as it's currently practiced and AGI. So that's where I think the brunt of our disagreement actually lies, not in just like the abstract, because
the general,
humans developing general autonomous agents to do things could definitely be a dangerous thing. I'm not sure. Yeah.
Okay, and that sounds like similar to what you were saying, Vaden, about your main like the gradient descent processes being like the thing that makes you skeptical of all of this. Is that right?
Yeah, totally. I think that the main techniques that are used are inductive in the sense of trying to generalize from observation. And for philosophical reasons, which we've talked about in the past, I don't think that generates new knowledge. And yes, I don't think that can create a artificially general intelligence system, at least in the same way that human beings produce new knowledge. And because I think knowledge kind of is created either through humans or through evolution, and evolutionary algorithms haven't seemed to step up to the plate and don't work very well. Maybe that's changing now, but so I totally agree with Ben. It's just, it's conceivable in the future, but I don't see any path from the current technology towards that. And I see most arguments about AI doom and gloom just kind of extrapolating forward current trends. Like, we've made a lot of progress, and so let's just keep imagining we make progress, and eventually we're going to create this thing that just takes off. And so so it's possible that in the future we'll have something that will change that, but at least right now I don't see any conceivable path towards it.
Okay, yeah, that's super helpful. And like, I guess I'm just pretty agnostic about whether it's going to be the current trends or it will require some sort of additional paradigm shift. But like, to me, it feels kind of either way, it's worth thinking about on a conceptual level, like that this could happen and that we should maybe be prepared for it. And like,
well, just one thing to say, like, there have been a couple times in the podcast where I've went on a long diatribe about AI safety, and then I've always take it out because there's a lot of very important work being done in AI safety research, such as, for example, like making these chatbots not say racist and misogynistic stuff, preventing recommender systems from propagating conspiracy theory videos. I think a lot of the work coming out of Anthropic is pretty great. Interpretable AI is all good. So if the AGI doom and gloom stuff motivates people to work on the more concrete, tangible here and now problems, then I'm for it. And that's why I take out, I think about my friend Rosie working AI safety when I go on my long diatribes, like, no, cut that shit out. That's not fair. And so I take it out.
Oh my God. So the stuff that I'm listening to is on your podcast is not even the worst of it.
That's the toned down version.
Wow.
There's a couple that I've been like, no, I don't want Rosie in particular to hear this. That's not fair at all.
No, that's fine. Yeah, so I think this is very helpful. Like, I do think there's kind of a straw man version of the set of views that people hold around AGI safety. Like, if you speak to most people who actually work in this field, I think they're a lot closer to what you're talking about. You know, we're trying to work out how do we get these models to not say toxic things, because that is an example of an objective that we have, and we're struggling to get that into the model. This is just like a small version of the bigger problem. There is obviously, you know, some people who are either not very good at communicating or have sort of views towards the like wilder end of the spectrum, that I think it can be tempting to sort of use that as the default. But I do think that there are a lot of people, like, there's like a much more mainstream version of these views that I think are worth taking seriously, I guess.
Can I ask a very specific technical question that has just confused me? That you may have the answer to and you may not have the answer to, and that's fine. So have you seen online Dan, the do anything now mode of ChatGPT?
Yes.
Where like you just prompt it in a particular way and all of a sudden start spewing out all of the garbage that you want. And so I saw that, I'm thinking, why don't they just not train it on like profane tokens? So like every time you have the word like poo or something, you just remove that word, and so it literally can't produce tokens that are profane. But like when I saw Dan, I was like, okay, so it knows how to say all this stuff. It's just somehow prompted not to. So do you know why they don't just remove profane tokens from the training data such that it can't actually produce it at all?
Yeah, we've experimented with stuff like this, and essentially the answer is it degrades the performance. Essentially you are removing. Again, you're handicapping its world model in a certain way by removing.
Swearing is key to a rich vocabulary. That's what's going on here.
Tell that to your parents.
Yeah, exactly.
I don't know if we've specifically tried it on profanity, but certainly in other sort of topics or areas that we wanted to minimize. Okay. We found that it just
doesn't work very well. Okay, that makes sense. Yeah. That makes sense. Yeah. Sorry, back to our regular scheduled program. I just wanted to ask that. That's slightly technical question. But Ben, you should check out Dan. It's hilarious. Like all of a sudden it'll just say literally anything. And it kind of is like, it's that easy to hack. You just have to prompt it in the right way. Yeah. And then all of a sudden
it makes me more concerned about AI safety if it's that easy to hack. Maybe they have a point. Actually, I have one more random question, which is that I saw on Twitter today a picture of Sam Altman with his blue backpack. And the caption was, he actually carries this everywhere in case he needs to blow up the data centers. Was that true? I think people were trolling?
I saw that and I 100% assumed it was a joke, and now I am like, what? Now I'm questioning that.
I looked up some other pictures of him, and he always has a backpack, and I was like, maybe it's true.
I have not seen him with this backpack around the office.
All right,
so
fair enough,
I assume it is not true. Though that might be maybe we should encourage that. Yeah. Maybe it's a good technique.
So you said earlier, maybe even before we started recording, that you had a number of things you wanted to kind of poke us on and questions you had for us. And I just want to make sure you had the space to ask those questions if they haven't come across already. But we've been interrogating you a little bit, so maybe it's fair to turn the tables around a little bit on us.
Yeah, I think a crux that maybe we have is this thing about creativity or knowledge creation being the true factor, the deciding factor between like whether something might be dangerous or not. I think that it may be possible that systems could create knowledge, and it also may be possible that systems are dangerous without that ability to create knowledge. And it sounds like you are pretty sure that if it couldn't create knowledge, it wouldn't be dangerous.
With a massive caveat, so computer viruses are dangerous but can't create knowledge.
Right.
So I think it's very possible that we create artificial systems that are dangerous and can't create knowledge. But if you say, no, Vaden, you have to limit the subject to only, quote, AGI.
Like catastrophic risks.
Then the catastrophic stuff, then I say, if it can't create knowledge, then I don't. Basically, almost by definition, I put it into the dumb camp, the computer virus camp. And I also recognize that talking about creating knowledge and creativity, like these words kind of don't mean very much when you overuse them. So I'm just going to default to Ted Chiang's criterion now, which is if you can't feed the output of a system back in as input and have it improve, then you're not creating anything new. I think that's a much more clean way to talk about what I'm trying to get at with knowledge creation and creativity in general.
Yeah, that is a helpful sort of benchmark, I think, to see if we reach that point.
But do you think that will ever possibly happen? Because I don't see how, because it's creating something from nothing. It's creating new ideas from.
But we do that, right? At least.
Well, but that's the big mystery. I know we do. So we do, and evolution does. And how the hell do we do it? And I have no idea, but I know it's not through just example after example.
Well, I don't know. I think it might be through example after example. Why shouldn't it be that?
Okay, so I can't just say because of Popper. That's not
yes,
refer to chapter 18.
Yeah. No, that's not fair. So because when you have an example, you need to have inbuilt structure which tells you what to look for and what counts as an example. So this is kind of the blank slateism. So ignore Popper and go to Pinker. You need to have some inbuilt structure in the mind which already exists before the examples start. And that inbuilt structure is a thing which one defines what an example is, because you need to have something which says this counts as an example. Like, so for example, like Georgia, my daughter, is learning sign language, and she's picking it up really quickly. It's really cool to see. But how does she know what counts as a sign? So if I like touch my lips with my fingers and that indicates like food, how does she know that it's not the backstroke, the moving the hand away from the mouth that counts as the example? So she knows, she has this inbuilt structure which allows her to process the sensory information she receives and then learn from it. And so the whole idea that you can learn from example purely means you have to have some blank slate, but this is like David Hume. What counts as an example can't be learned by example because you need to start from something. And so you need to have some inbuilt structure. Yeah.
Right now it's provided by the programmer is his point for
right now it's provided by the programmer and the data collector and the person who decides what's a row on the CSV. And we don't know what it is that human beings have inbuilt evolutionarily that allows us to take a continuous stream sensory information and chunk it into learnable sequences. But we know that for machine learning applications, it's human beings that do that. Human beings take that amount of data and they say, this is a row, this is a row, this is a row. So you can't learn purely from example because it's almost a contradiction. You need to have learned what counts as an example first. And that can't be taught by example.
But I don't understand why if we can do it, we think that a machine definitely won't be able to do it. Or I guess this is just within the current paradigm you're talking about.
Yeah.
Okay. So within the current paradigm, so we can do it because we have 500,000 years of evolution, which has slowly created these genes, which create the survival machines, which just going back to Dawkins, which Ben and I are reading now.
But evolution. Okay. Yeah. I guess maybe the key thing is like, you're not saying this is impossible in general. You're just saying it's impossible with current paradigms. Because to me, it's just like, evolution managed to do this in a non-directed way and it worked. If we're like consciously, physically trying to do this intentionally, surely we will be able to do it, given that's this other optimization process managed to do it kind of by accident.
Well, I think surely is a bit strong. Like
surely is a bit strong.
We might be able to. It like we have to guess. We have to guess the right answer. And whether or not we guess that is not preordained. There's no guarantee we're going to.
No guarantee.
It depends on funding. Sure. It depends on interest. It depends on 1,000 different factors.
But it seems very strong to be sure that we won't.
Oh, no, I'm not sure that we won't. I'm sure it's possible because human beings have done it. And I'm also sure that the current techniques we're using won't get us there for philosophical reasons that we've talked about in previous podcasts.
And do you think that the whatever is needed in terms of a paradigm shift to get there, you just think we are like way, way off from that? Or like, would you be surprised if that happened? Mm-hmm. Yeah,
so I really like Eric Larson. So the name Eric Larson isn't as well known as it should be, but he wrote a book called The Myth of Artificial Intelligence. And it's a great book. And he talks about how the AI field has alternated between two paradigms. The first paradigm is deductive, and the second paradigm is inductive. And so deductive AI is all about starting with rules and then deriving the consequences of the rules. Inductive is all about starting with examples and trying to derive generalizations from these examples. And neither of these two are going to lead to intelligence because human beings do a third thing called abductive reasoning, which is basically like conjecture and refutation, but he's using the philosophical framework of Charles Peirce. And you can kind of think of abductive as guessing the right deductive rule from an infinite set of possible things you could guess. But abductive reasoning is not as well understood. And so as long as we are operating under either of these two paradigms, deductive or inductive, we're not going to get general intelligence because human beings do this third thing, and we have no idea how to even start coming about this third thing. So I see all of current,
What you're saying is we just need to make sure no one starts researching anything to do with abductive reasoning, and we'll all be fine.
Well, but so even there, like I think the only thing I could say with confidence is that it would be possible to create something with human level intelligence. So that's another aspect of the AGI conversation is they describe this system which is just superior to human beings in every possible way, and then they're terrified of this like creation of theirs. When the only thing I could say with confidence is that it's possible to make something that's human levelly smart, and that isn't terrifying because every time you have a child, you're creating something which is human level intelligence.
Yeah, I think that might be a bit of a straw man of the views, at least for my view.
Okay. So correct me then, yeah.
Yeah, it's going to be better than humans on all these different dimensions. It's just on like a few key dimensions that we are specifically optimizing it for because those things are likely to be useful for other goals. So, being very good at persuasion, being very good at coding, being very good at modeling the world, strategic planning, those kinds of things, I think are the key areas. Probably more.
But there's no guarantee that we'll create a system which is better than us at all of those.
But we shouldn't be confident that we wouldn't, right? Like, there's lots of things that we have many computers better at than we are.
So I guess I'm going back to when you said, so nobody work on abductive reasoning because the idea there is if you start working on abductive reasoning, you're going to necessarily create something which is better than us at reasoning and goal-directed planning and strategy. And it's like, well, no, we might create something which is as good as us at that kind of thing. But Human beings learn very slowly. Human beings learn over the course of 25 to 30 years. What is it, the factoid that the brain doesn't fully develop until it's like 20, 28 or something?
Why would there be that limit on it?
I'm not saying there necessarily is a limit, but I can say that the existence proof that human beings are evidence that we can create intelligent systems only goes as far as human being level intelligence. It doesn't prove that we can create something that's further than human beings. But
we even humans are getting smarter over time, right?
Yeah, like the Flynn effect is real. But I cannot say with certainty it's possible to create something which is better than human beings at the dynamics or the dimensions that you have adumbrated.
Yeah, and I think this is the key thing. I'm not claiming it is possible with certainty. I just think that we shouldn't be confident it's impossible, and if it would be really scary, that if we could do that, then we should consider how we should handle that situation.
So maybe so I don't know if it's possible to answer this, but if you were to just I feel like since the beginning of the conversation, I've been getting bogged down in exactly what you're concerned about. So I don't know if I figured it out yet, but can you give me a percentage of 30% current reinforcement learning systems versus 70% some unknown thing that's going to happen? What in terms of what you're concerned will go off the rails eventually? Is it how much of it is concentrated on, because you used reinforcement learning a lot as an example, right? So how much of your concern is concentrated around that specifically, and then how much on some unknown thing that you're just worried about us pursuing and that potentially goes wrong? And so if you had $100 billion, right, how many billions would you put on reinforcement learning safety? And then how many billions would you put on just, okay, hold this in reserve for when the next crazy paradigm comes around and shit hits the fan, right?
Oh, interesting. So I can invest that in safe. Yeah. Okay.
Yeah, exactly. You can invest it in making sure current RL or even, whatever you want.
That is very interesting.
What I'm trying to get a handle on is how much this is just a personality characteristic of being concerned about things we don't know about the future, right? Versus concerns about sort of existing problems that you think could scale up very quickly and get out of hand. And so I think because there's a big part of the conversation that Vaden's just, not concerned about the future. He doesn't care about the future at all. And you just,
for tomorrow.
Yeah, he doesn't give a shit. And then you're just, concerned that something could go wrong if we, start researching something new, et cetera. So putting that aside, I'm trying to figure out how much of the rest of the disagreement
is about specific technology getting out of control compared to an amorphous threat in the future that we don't have defined yet. Yeah. Great question.
Okay. So I'm allowed to assume that we'll scale up computation, we'll scale up data, we'll not create new data, or am I allowed to assume we'll create new data? Okay. Well, maybe this. Yeah. No, but in terms does creating new data count as a new paradigm, or does that count as within current systems?
No, so fuck it. Just say unlimited data and then sort of reinforcement learning with unlimited data. Let's just go with that. Yeah.
Reinforcement learning with unlimited data. I think that I am pretty concerned that could get us to the systems that would be very dangerous. Mm-hmm. So I think this is a crux between us. You guys don't think that the kind of gradient descent optimization type stuff will get us there, whereas I think that seems pretty plausible that we would.
And that will get us to agents that have the ability to take over the world on their own, not just things that can be used by humans to do dangerous things. That could create an agent that could basically single-handedly destroy the world's economy, etc.
That I think it could both have the capability and the propensity to cause catastrophic harm to humans.
Okay. Wow. Yeah. Okay. Well, that's definitely a big. It's a big distinction then. Yeah. Okay.
Yeah.
That's helpful. Oh yeah. So I think there's some amount of chance that everything will just be fine by default, which I think maybe is where you guys are, which is just this is just like any other technology. We just don't need to worry at all. Everything's going to be fine. Mm-hmm, mm-hmm. I think this.
Or we need to worry as much as we do with any other technology, which is we need people.
But it's not going to take over the world.
I'm glad
do anything kind of irreversible.
It's nothing we haven't done. Yeah, exactly.
So I think there's some amount of probability on that. There's some amount of probability on if we march towards this goal, there's just really not going to be anything we can do to avoid the harm or the catastrophe. And then there's some amount of probability on we're marching towards that, but we are putting effort into the right places in terms of interpretability research, in terms of like other safety engineering approaches that will constrain it in a certain way. And so we'll sort of shift everything to be fine. I think right now I'm like roughly equal on those three outcomes. That could just feel fine. It could be completely doomed, or it could be that what we're doing right now is going to make the difference.
Yeah. So would McCaskill call it like the hinge moment?
Oh,
like
right.
It's a hingey thing. Like what you're doing right now could make the difference between it being fine or it being very opposite of fine.
Or I don't necessarily mean like right now, but I just mean like the sort of community of people and the efforts that are currently and will in the future be going towards these kinds of solutions, some of which are solutions to solve like current day problems, like not making it say racist things or not making it do ruthless optimization for recommendation systems. All of that stuff is going to like maybe get us on the right track to avoid.
So maybe we can start winding things down and end on kind of a note of less disagreement. I'm curious to know your thoughts on what are the most promising sub areas of AI safety, what you're most excited about, what you think is most likely to bring about a good outcome, and what maybe you wish was better known about the AI safety from people, community from people outside it.
I think, I've mentioned interpretability a few times. I think that's a pretty obvious one.
And maybe just define for the audience.
Yeah. So it's basically when a system is making a certain decision or it has certain outputs that we can kind of reliably know by inspecting the system itself why it did that and like what it's attempting to do, which I think differs a little bit from explainability, which is getting the system to produce an explanation for why it did that thing, which may or may not correspond to why it really did that thing. So it's like how can we be really sure that it is like we kind of have transparency and visibility into what it's doing and why. Other approaches to AI safety, I'm probably not the best person to ask because I think there's a lot of interesting different directions to go in, and I'm like very glad that people are pursuing these things, but I haven't like spent a lot of time in depth looking at them. Reinforcement learning from human feedback, I think, is one of these weird ones where it's like both a capability enhancer and potentially a safety enhancer, but it has some pretty significant flaws when you consider it as the only safety enhancer in terms of like the systems being incentivized to make you reward it for, like, have you seen the one where it's like got the hand in front of the item? Have you seen this one? Where it's like,
is that what the OpenAI like manipulating a Rubik's Cube?
No, I think that's a slightly different. This is where basically, it was like reinforcement learning to try and get a system to like in a virtual world, like pick up an item. But because you only have a 2D view on it, you're like rewarding it when it gets close to the item. But so like if my hand is over that microphone now, which, I know we're a podcast and so visual stuff is not going to be great for listeners, but like you would like reward me for covering the microphone, even though like I'm nowhere near the microphone really. And so this thing, so this is one of the main problems with the human feedback approach is that like you're giving it feedback, but it's still learning the wrong thing because you don't have the full picture or the full information. So I think this is how I feel with like quite a lot of the AI safety approaches, which is that they seem valuable in certain dimensions, but also have potential flaws that have yet to be resolved. And I haven't seen any that are like completely like, this seems like a robustly reliable approach to solving this problem.
And didn't Miri just totally give up on the project? Is that accurate? That they kept coming up with solutions that couldn't that weren't robust, and then just said it was too hard and are not working on that? I may be misinformed. So if that doesn't land with you, then
I'm not sure if they've totally given up, but I think that some of the avenues they were pursuing, they basically came to the conclusion that they weren't going to pan out. I'm not sure what the exact latest is though. But yeah, I mean, to me, I think like there's probably a bunch of avenues that even if you're not sure are going to pan out, they're still probably worth pursuing. But yeah, I don't think we have anything that's like a perfect solution yet.
Yeah, interesting. Well, it's good that we have people like you working on
it. We'll see.
Nice. So it sounds like the major crux, basically, except for the future stuff, basically just comes down to like the capabilities of current models to develop like a sense of truth, a sense of agency, a sense, like an actual very representative world model. Like Vaden and I remain on the very skeptical side. You remain on the possibly more neutral to the yes, this is happening side. The problem is we could spend a long time debating the feasibility of that, and there continues to be daily archive papers on either side of the issue. A lot of them just being absolute crank work, but sadly, I don't think we could resolve that here. But I guess at least we've clarified where we think the dangers lie.
This was super helpful for me. I appreciate it a lot. Thank you.
Cool. Well, it was an absolute blast having you on. Do you want to maybe let people know where they can find more of your work and perhaps follow you on Twitter and all that good stuff?
Sure. You can follow me on Twitter at Rosie Campbell. I have a website, which is rosiecampbell.xyz, which I rarely update, but I probably should start blogging more. I was thinking about starting a blog soon on AI specifically. And if I do, maybe I should ping you the name of that.
Totally, yeah.
I decide on that.
We'll send it out, yeah.
Thank you,